Okay, now I got me a graph up here. Good. Now, just to remind us, I put this X beside burgers because X is the number of burgers and the Y beside fries because that's that number of orders of fries. Okay. Likewise on my axes, Y for fries, X for burgers. Now let's graph this on that. Now don't forget, this is in standard form. So remember, for standard form, we could use our cover up intercepts method to graph this line, right? So remember, if I want to find the y-intercept, I cover up the x. Remember, the x value is 0 at the y-intercept, right? So I can cover that up. Solve this by dividing both sides by 3, and y is equal to 10. Yes, the y-intercept will be 10. I would do the exact same thing to find the x-intercept. Cover up the y because the x-intercept, the y value is 0, and solve this equation. Divide both sides by 5. You get x equals, 6, and you just connect those dots with a line. Now, we can also change this into slope-intercept form. Remember how to do that? Yeah, it's going to look something like this. Yeah, exactly right. You remember that from the video. We just took the x thing, the 5x, moved it over as negative 5x, and divided everything by that 3, and this is what we got. So if I graph this, it will be the same exact line. Y-intercept 10, bang, slope negative 5 over 3, down 5, right 3, look like this? Yes, exactly like that. That's exactly what that line would look like. Now, remember, because this is an inequality, that line could be dotted. If this line wasn't there, if this just said y is less than, that would be a dotted line. And now don't forget the shading. Yeah, we got to shade everything less than or below that line, like this. Good, exactly right. Now, let's talk about this situation and this word problem right here. Notice how when I shaded this entire side of the graph, right? Even the negative numbers. In this situation, do I need negative numbers? Can I have negative burgers and can I have negative fries? I don't think so. That's going to change this graph a little bit, isn't it? If I took away the negative numbers of this graph, what would it look like? Yes, that's exactly what it would look like. And when you think about it, this number of burgers, this x, doesn't it have to be greater than 0? Yeah, I guess it could be equal to 0 because you could order 0 burgers, right? Well, if I ordered 0 burgers, then I could afford 10 fries. This is making sense now. Well, what about the fries? Shouldn't the fries be positive also? Shouldn't that be greater than 0? Yes. Now, I could order 0 fries, and that means I could afford 6 burgers. Yeah. But for a second, let's talk about these equations here. Remember, in an inequality, we have a solution space, right? So if I'm talking about all of the graph that's below this line, but greater than 0, x has to be greater than 0. Well, wait a minute. Isn't that a line also? The line x equals 0 looks like this. Yeah. And it kind of like sets this left boundary, right, for my little solution space. Okay. Well, what about that y equals 0? Yeah, that sets the bottom, right? Because I want everything bigger than that. And I want everything bigger than that. But I want everything smaller than that. Yeah, well, so this line has an equation, this line has an equation. Doesn't this line have an equation? Okay, so these lines that form our solution space, there's a name for them, right? It depends on your teacher, it depends on the book, but they've been called everything like boundaries. These equations can be called boundaries because they are the boundaries to our solution space. Yeah, they're also called constraints. Yeah, there's one other one that you're going to get, but not for a while until you get the calculus. Governing equations. Yeah. So these equations form my solution space. And don't forget, this entire shaded area is my solution space. So everything in here I can afford. Yeah. Let's talk about some of the combinations that are in here, right? Could I afford 3 burgers and 4 fries? Yeah, it's in my solution space. But could I afford 7 burgers and 10 fries? No, there's no way. I don't have enough money. It's not in my solution space. This solution space gives every combination that I can afford. Yeah, and if it's on the line, I can afford it because I can spend all $30. Now, if I couldn't spend all 30 and this was dotted, then a spot on the line would not work because then I would be spending all $30. Yeah. Man, I hope this helps. Check the next video out because I got some more word problems for you. I'll see you there. Okay, bye.